Hello students, once again welcome to this lecture. These are the topics to be covered as part of this lecture. So already you are familiar with the basic concepts related to the ER model: entity, attributes, entity types, relationship type, entity set, recursive relationship. So all those things we have covered as part of our previous lectures. So in this lecture, so what are the constraints on relationship? How to represent the participation constraints? How to include an attribute for a relationship type? And finally, I will take a case study and I will explain a step-by-step procedure to construct a ER diagram for another problem statement. So first we will start with the constraints on relationships. So with respect to the key constraint, there are four possible key constraints. So what is the use of these key constraints? These key constraints are used to express the number of entities to which another entity can be associated via a relationship. You are having a relationship type. So what I can do is I can add a constraint such that I can specify how many number of entities of one entity type can be associated with another entity type, entities of another entity type through a relationship type. For example, suppose you assume that you are having two entity types, namely A and B, or two entity sets, namely A and B. So there are four possible mapping cardinalities between these two entity sets, namely A and B. So what are the four possible mapping cardinalities? They are: first one is one to one, second one is one to many, third one is many to one, and fourth one is many to many. Now, so what is the idea behind this one to one? So the explanation is, and now you are having two sets, namely A and B. An entity in A is associated with at most one entity in B. And if you take an entity in B is associated with at most one entity in B. So what is the idea behind one-to-one mapping cardinality? An entity in A is associated with at most one entity in B, and an entity in B is associated with at most one entity in B. So I will give you one example. Now suppose, so a practical example, a man may be married to at most one woman, and woman may be married to at most one man. So what is the other possibility? Both men and women can be unmarried. So what you have to infer is, so this diagram, okay, so this diagram is not part of any ER diagram. So this is used to explain the concept. So now, what is the relationship between men and women? So what is that? So you are having two entity types. Entity type A is men, entity type B is woman. So don't get confused. So this is the notation used by some other authors. Usually you can have a straight line, and this is also a possible notation. Okay. So one entity type A is men, entity type B is woman. So according to the one-to-one mapping cardinality, so what is the constraint is, an entity in A is associated with at most one entity in B. So a man may be married to at most one woman, and a woman may be married to at most one man. So that is the relationship. So what is the relationship type? Relationship type is married to. So don't bother about these things, that I will explain later. So this is an example for one-to-one relationship. Okay. So a man, entity in A, is associated with at most one entity in B. So a man may be married to at most one woman, and a woman is may be married to at most one man. So now, according to this problem statement, so it is possible to have what? So part of this relationship type. What is the relationship type? Is married to. It is possible to have both unmarried man and woman. So here you are having a unmarried. So this man is not related to. So this entity from entity type A is not related to any entity on entity type B. So as with respect to this problem statement, it is possible to have unmarried man as well as unmarried woman as part of this relationship type. So what is the second condition? One to many. If you take an entity in A is associated with any number of entity in B, but in the reverse, that is vice versa. So an entity in B is associated with at most one entity in A, one to many. So clear? An entity in A is associated with any number of entities in B. An entity in B is associated with at most one entity in A. So now an example for one to many mapping cardinality. So what is the relationship type? Relationship type is mother of. You are having two clubs. One is women's club and another one is low IQ club. So now a woman may be a mother of many or no children. But if you take that is, this is an entity in A. A woman may be a mother of many children. But an entity in B, a person may have at most one mother. So a person can have at most one mother. So now if you take this person, okay, so here according to this example, what they say is your author, the person name is going to be Mo. So it doesn't mean that Mo is not having any mother. So what is the biological fact? If you take a person, obviously they will be having a mother. So now here, what is the inference is, the mother of this person is not a member of this particular club. Here, one to many. One woman, okay, a woman may be a mother of many children. One to many. Okay, but if you take a person can have at most one mother. Okay, one to many, then many to one. Okay. So next one is, okay, so what is the next mapping cardinality is many to one. An entity in A is associated with at most one entity in B. An entity in B is associated with any number of entities in A. So exactly vice versa of one to many. Many to one means an entity in A is associated with at most one entity in B. An entity in B is associated with any number of entities in A. Okay. So now if you take this example, so relationship between a person and a country. So many people can be born in any country, but an individual is born in at most one country. So now the thing is, what is the relationship type? Relationship type is was born in. So you are having two entity types. One is bowling club and another one is country. So the attribute for this country is going to be capital. The attribute for your bowling club is going to be name. So many to one. So if you take this case, so for this country, okay, so many people can be born in a country. Okay. But if you take a country, okay, any individual, okay, so if you take an individual is born in at most one country. So that is the relationship between many to one. So now in this diagram again, okay, so if you take this Ireland, so what I am trying to say is it doesn't mean that, so actually you don't have an entity from this A is associated with this entity in B. So it doesn't mean that no one was born in Ireland. So as of now, the persons, okay, so you don't have a person who is part of this particular bowling club, okay, with the Ireland, okay, so who was born in Ireland. And another thing is, if you take this sea captain, so this sea captain is not associated with any country. So here the idea is we don't know the country name for this particular sea captain, or the country is not part of this water. Country is not part of this entity set. So that is the idea behind your many to one. Many entities from entity type A is associated with one entity in. So that is the idea. So an entity in A is associated with at most one entity in B. An entity in B is associated with any number in A. Okay. So finally, the last mapping cardinality is many to many. So entities in A and B are associated with any number of entities from each other. So now among these four things, okay, so what, so you may ask a question, sir, which constraint I need to select? So it depends on the what? It depends on your problem statement. So now we will take one example for many to many. So with respect to this many to many, so one entity type is girls and another entity type is boys. So what is the relationship type? Is classmate of. Okay. So many girls. Okay. So many entities from entity type A is associated with many entities from entity type B. Okay. So a girl is associated with what? So if you take this example, so a girl is associated with many boys. Okay, so if you take this boy is associated with or this boy is classmate of these three girls. So this girl is classmate of these three boys. Okay. See, I have taken this scenario only for example purpose. Okay. So these are four practical examples to explain the various mapping cardinalities. So first one is one to one, second one is one to many, third one is many to one, and fourth one is many to many. So next idea is about participation constraints. Now we will modify the problem statement. So earlier we saw one example for one-to-one key constraint. So you remember this problem statement. So what is the problem statement? A man may be married to at most one woman, and a woman may be married to at most one man. So now see the next line, both men and women can be unmarried. Now we are going to modify this problem statement. So now a man may be married to at most one woman, and woman may be married to at most one man. Both men and women can be unmarried. So this is the problem statement for the example what we saw for one-to-one key constraint. Now you want to build a database for Springfield Christian Married Persons Association. So now what is the constraint? So everyone must be married. So in database terms, their participation must be total. In the previous case, it allows unmarried people. So it is said to have partial participation. So now the thing is what? So if an entity, so the thing is, so as part of this relationship type, you can have only the married person can participate in this relationship type. So now how to represent this constraint in the ER diagram? So the answer is given in the next slide. See the two different notation. So you can have two types of participation constraints, namely total participation and partial participation. Another name for total participation is existence dependency. So what is the notation? So notation used for total participation is double line. Notation used for partial participation is your single line. So with respect to our company database, so the thing is what? So here an employee. So what is the relationship type? Managers department. So what is the relationship of what is the constraint with respect to department and the managers? If you take a department, according to our problem statement, it is mandatory to have a manager for that particular department. So you are going to have the entity type department is having a total participation in the relationship type managers. Whereas if you take employee, we are not going to have a condition saying that all the employees are managers. Employee belongs to a department, but among the employees, one is going to be the manager. So all the employees are what? All the employees are not managers. So the participation of employee in the manager's relationship type is going to be partial, whereas participation of department in the manager's relationship type is going to be total. Now on the other hand, so according to our problem statement, if you are going to have if you claim that a person as an employee, then you cannot have an employee without a department. If you take a department, it consists of some employees. That is, employee, each and every employee belongs to a particular department or only one department, that is this one. If you take a department, it can have n number of employees. Okay, so clear. So what is the idea behind total participation and the partial participation? So what is the notation? For total participation, you need to use double lines. For partial participation, you can use single line. That is, all the entities from that entity type is not going to participate in that relationship type. Then it comes under the category called as partial. If all the entities of that entity type participates in that relationship type, it comes under the category called as total participation. So next terminology is attributes of relationship types. So if you see the discussion what we had so far, usually an attribute is associated with your entity type. So if you take the previous case, see here, department is an entity type. So you are having some set of attributes. So now in addition to this, what we can have is, so for better understanding, you can associate an attribute to your relationship type. So if you remember the problem statement, so for each and every department, you are going to have a manager. And what is the information you need to store with respect to this manager? You need to store the start date. So if you are going, so what you can do is, so here you can have one attribute as start date. But if you move that attribute to this relationship type, it will be more meaningful. So that is the idea behind what? That is the idea behind your attributes of relationship types. So a relationship type can have attributes. If you take the previous example, for managers, you can have start date is the attribute for the relationship type called as what? For the relationship type called as managers. So in this case, okay. So for works on, what is the attribute? You are going to have hours. So now what they say is king. So number of hours the employee works on a particular project depends on the what? Employee project combination. So now the question is, see, diagrammatically what you can do is, in the ER diagram, you can represent this attribute as part of your relationship type. But in the next stage, that is logical implementation, practical implementation. So if you are going to convert this into a table, your entity type will become the table name and the attributes will become the field name. So we are not going to create your relationship type will not be represented as a table. Then in that case, where to store the information about this attribute? What are the options you have? So that is the last thing. Suppose depending upon the cardinality ratio. So if you are going to have 1:1, you can move it to what? You can move it to any one of the entity type. If your relationship type is going to be 1:n, then what you can do is, then you need to transfer that attribute to the n side of the relationship. So now in this case, suppose here, so here 1:n. Suppose here 1. So in this case, you can keep the start date as part of this employee or department. Whereas here, so works on this hour always move to what? Always move to the n side of the relationship type. So that is the last point. So what are the notations we are going to use for specifying the constraints on relationships? So if you take a binary relationship, so the cardinality ratio for binary relationship are represented in your ER diagram by displaying 1, m, n on the diamonds. Okay. Now see here. Here you are having 1, here you are having m, here you are having n. So here also you are having n, here also you are having 1. Okay. So this 1 and n, 1, m, n represents the what? Represents the constraints. So the thing is, so so according to this notation, what we are trying to do is, we are trying to incorporate a constraint saying that. So if I keep the letter as n, I am saying that there is no restriction on the number of maximum. If the value is going to be 1, then in that case, at the maximum only one entity can participate in that relationship type. Okay. So for example, in this case n, so one employee manages one department. So if you remember our problem statement, so with respect to a project, your project can have any number of employees. An employee can work in more than one project. So we are using what? M and n. Okay. So in this case, 1n means, so for one person, one supervisor can have how many supervisee? Okay, you can have n supervisee. So a department can have n number of employees, but an employee is associated with at most one department. See, again, it is a convention according to the author. So in some cases, so here they have used in the other direction. 1 represent what? One employee. N is related to this entity type of department. In some other textbook, the notation may be reversed. So in addition to this 1, m and n, in some cases what you can have is, you can have the value as 4 or 5. That is, at the maximum only 4 entities from the entity type can participate in that relationship type. So all these values 1, m, n are derived from where? Are derived from your real world constraints or real world scenario, or from your problem scenario. So for example, now you take, so a department has exactly one manager and an employee can manage at most one department. See here, so what is the relationship? Managers. Okay, so you can represent it as what? You can represent it as 1, 1. So in the other example, an employee can work for exactly one department, but a department can have any number of employees. So in the case of works for, okay, an employee works for only one department, but if you take a department, you can have n number of employees. So this is additional additional notation you can use to represent the constraints on the relationship. So in some textbook, they will be using the constraint. These constraints are called as what? Min-max constraints. So this is the final version, okay, of your ER diagram. So if you see this ER diagram, so what are the concepts we have discussed so far? So all those concepts is incorporated in this ER diagram. Entity type, attributes, relationship type, various types of attributes, total participation, partial participation, recursive relationship, strong entity type, weak entity type, partial key. So in the here the difference is, so here name is, so here you are having this attribute is solid line. So solid line means it is a key attribute, dotted line means it is a partial key. So all these things we have covered as part of the explanation. I have given explanation for each and every notation. Now, so as a summary, what are the notations we have used in an ER diagram? So entity, rectangle represent entity, double rectangle weak entity, diamond shape the relationship, double diamond identifying relationship. So this is the notation, single vowel for attribute. So if you are going to have an underline key attribute, double vowel for multi-valued attribute. So this is the notation for your composite attribute. And this dotted vowel is for derived attribute, double line is for total participation. So 1n is for your cardinality ratio. So you can specify what 1 comma n as a min-max constraint. Okay. Now, so alternative diagrammatic notation. So the thing is, so based on the discussion what we had so far, don't come to the conclusion that only option we have for representing the database in diagrammatic form is to use only what? ER diagram. So apart from ER diagram, we are having some other options also. So your ER diagram is one popular example for displaying a database schema. So you are having some alternate notations. So one notation is, what you can do is you can use UML class diagram. Okay. So this is the equivalent UML class diagram for the same problem statement, that is for the company database. So what I want to highlight at this point is, you don't have this UML class diagram as part of your syllabus. This is only for understanding. So this is not important from exam point of view. So I want to compare ER diagram with I want to just introduce the other notation, other diagrammatic representation. Okay. So here your entity type is represented in the form of a class. So you will be having three combinations. That is, it is divided into three components. Here, in the top you will be having the class name. In the middle portion you will be having the data members. In the bottom portion you will be having the operation. That is the difference. If you take a ER diagram, the operations are not represented as part of your ER diagram. Whereas in the case of UML class diagram, so what are the operations you can perform with respect to this class is mentioned or is included along with the class definition. So again, so this is the notation for your constraints. So this is the relationship type, relationship attribute. This is the notation for your recursive relationship, weak entity. Okay, so weak entity, that is dependent. Okay, so this is the alternative. So this is the notation what we have to use for creating a UML class diagram. Okay. So this is just for comparison with respect to your ER diagram. Okay. As a whole, so what are the concepts we have discussed so far? We have discussed the idea related to entities, attributes, relationships. So what are the constraints in the ER model? using ER in step-by-step conceptual schema design for the company database. And finally, again I have listed the various notations what you can use for creating a ER diagram. Next, we will take another simple example. Okay. So now consider this problem statement. So a university consists of a number of departments. Each department offers several courses. So a number of modules makes up each course. Students enroll in a particular course and take modules towards the completion of that course. Each module is taught by a lecturer from the appropriate department, and each lecturer tutors a group of students. So this is the problem statement given to you. For this problem statement, what you need is you need to generate a ER diagram. Now, first step is what? You need to identify the entity types. So, in the first line, an university consists of number of departments. So, what are the so for this problem statement, what are the entity types? One is going to be department, course, modules, student, lecturer. Okay, so these are the entities what you can identify for this particular problem statement. Then what is the relationship? So department offers. So what is the relationship between department and course? Offers. What is the relationship between modules and course? Makeup. What is the relationship between student and course? Enroll. So what is the relationship between course and modules? Take. So relationship between module and lecturer, taught by. So you need to identify what? From the problem statement, you need to identify the appropriate relationship type. Now see. So what are the entities we have identified? Department, course, module, lecturer and student. For the given problem statement, we have identified 5 entity types. So next one is relationship. So department offers a course, or this course is offered by the particular department. So if you remember the problem statement, each department offers several courses. So what is the relationship between department and course entity type? Offers. Now, so each and every course consists of various modules, or a number of modules makes up each course. So what is the relationship? Includes. Course includes module. Then what is the relationship between student and course? If you take a student enrolls in a particular course. Okay. Next one is, so if you want to, as a student, if you want to complete this course, first you need to finish all the modules. Then student takes a module. So this module, okay, so your lecturer is going to teach each and every module. Each module is taught by a lecturer. So your lecturer belongs to a particular department. So your lecturer is from an appropriate department. And finally, what is the relationship between lecturer and the student? Your lecturer tutors the student. So each lecturer tutors the group of students. So for simplicity, in this ER diagram, I have not included the attributes. So this is not a full-fledged ER diagram. So for easy understanding, your attributes are removed from this basic ER diagram. Okay, so this is the complete ER diagram for the given problem statement. So thank you.